This is Unit 3, Day 6. We're starting off with example 38 here, quadratic inequalities in one variable. All right, if you remember back in algebra, we talked about the inequalities. Inequalities just simply mean greater than, less than, greater than or equal to or less than or equal to, okay? Well, right from the beginning, if you can memorize that an and is a conjunction, and that is for all less than or equal to's, okay? So conjunctions are all for less than or equal to's. Graphically, that means they're connected, okay? Obviously, they're filled in if they're included, or they're called closed, or you would leave them open, okay? Don't shade them in if they're not included, meaning they're not equal to, okay? The opposite of and in math is or, and the opposite of a conjunction is a disjunction. Okay, disjunction is always for greater thans or greater than or equal to's. So that's when they shoot out in opposite directions, okay? So those are or statements. So if I look at example 38 here, these are pretty easy. It says, at the heart of solving any inequality, it is finding all the values of the variable or values that make the inequality true. The basic notion of inequalities is critical to understand before proceeding. Determine if each of the following is the solution to the inequality given. Show your work to justify a response. These are pretty easy. This is just done by substitution. So if you just substitute in a 4, you're going to get 4 squared minus 3 times 4 minus 10, and you're going to see if that is greater than 0. Well, when you solve all that work, you're going to get negative 6 is greater than 0. That is false. Negative 6 is not greater than 0. Therefore, you know that x equals 4 is not a solution for that inequality. Okay, same thing's going to happen here on letter B. So you're going to substitute in a positive 2. So it's 2 times 2 squared plus 13 times 2 minus 7 is greater than or equal to 0. Okay, using order of operations or PEMDAS, you're going to get that 27 is greater than or equal to 0, which is a true statement. Therefore, you know x equals 2 is a solution. Okay? Last one here is negative 3. Be careful. Anytime you have a negative number, you have to put it in parentheses. So you're going to get negative 3 squared minus a negative 3 minus 12 less than 0. And don't forget here in the middle, that double negative becomes a positive. So you're going to get 9 plus 3 minus 12, and you end up with 0 is less than 0. Well, 0 is not less than 0. 0 is equal to 0, so that's a false statement. So x equals negative 3 is not a solution. Oops. All right, moving on to example 39 here. It says most of the time there are an infinite number of solutions to an inequality. The solution set of the inequalities like these cannot be written in roster form where one lists the solutions. In this example, we will explore how to determine the solution set by using table of values on your calculator. Okay, so consider the quadratic inequality x squared plus 2x minus 3 is less than 0. Part A, solve the corresponding equation algebraically. So if you guys notice here, to solve this, you change the inequality to an equal sign, and you're going to factor old school. So you're going to say what multiplies to give you a negative 3 but adds to a positive 2, and you're going to get x plus 3 and x minus 1. At this stage, you split it down the middle, and you set each one equal to 0. So when x plus 3 is equal to 0, your solution is x equals negative 3. When x minus 1 is equal to 0, then that's equal to a positive 1. So we get negative 3 and positive 1. Part B says, using your calculator in the equation, y equals x squared plus 2x minus 3, fill in the table below. All right, so I just actually put this on a graph page and then hit Control-T and put a table of values, and those all get filled in for you. And you don't have to do any thinking mathematically here. Those table of values will produce this for you. So you can see where the turning point is there, because it had, oops, I'm sorry, messed up there. Okay, so you can notice the pattern. So -1, -4 is my turning point. All right, part C, explain why the zeros you found in part A are not a part of the solution set of the inequality. Okay, well, the zeros, thinking the roots, right? Because up here in part A, these are the roots. That's where the parabola crosses over the y-axis, okay? Zero's not included in here, because if you go back to the original, it's strictly less than 0, okay? And because it's strictly less than 0, 0 is not included, okay? So the zeros, aka the roots, the x-intercepts, the solutions, are not going to be included because it's not equal to 0, okay? Because 0 can't be less than 0, okay? That's not true, okay? Part D, write the solution set of the inequality and represent it on a number line. All right, so now if you guys remember, from the beginning here, we knew that this was less than. So up top in the margin when I very first started, because it's less than, you know that they're connected, and you know it's a conjunction, meaning it's an and. It's sandwiched between two numbers. So my solutions were -3 and +1 that we found in part A. So it's -3 is less than x is less than 1. And it's strictly less than, it's not equal to, because that's what it originally gave us, okay? So that's set builder notation. Interval notation, it's going to go from -3 to +1. Neither number's included because it's not equal to. And then on a number line here, here's my -3, here's my +1. They are a conjunction, which means they're connected. So, and I don't fill them in because they're not equal to, okay? So every single less than or equal to will be sandwiched in between two numbers like this, okay? It'll always be this way. And then the picture of the graph is always connected like this. All right, moving on here to example 40. It says the key to algebraically solving a quadratic inequality is to first find the zeros and then test the points between them. Okay, again, you don't really need to know your test points. So look at this right here. That's greater than. So if you guys can memorize what I just taught you a minute ago, we talked about how that is a disjunction. That's an or. So you know it's going to be going two separate ways like this, okay? And this is a DPS. So if I were to solve that, that becomes x plus 2, x minus 2, split down the middle, and I get it's -2 and +2. So I know I have to get both solutions. So it's not 1, it's not 4. Those are just thrown in as distractors. But then if you look, I know it's an or, because any greater than or greater equal to's are ors, so you automatically know it's choice 3. Okay? All right, now for 41, we're going to solve each of them. We're going to put them in interval notation, set builder notation, and on a number line. All right, so ready? First step, you have to factor these old school like it's an equation. So you're going to say what two numbers multiply together to give you -36, but add to -5. It's x minus 9 and x plus 4. Split down the middle, and you're going to get x equals +9, x equals -4. Okay? Also notice, this is a less than or equal to, so that means it's sandwiched together. It's an and, it's a conjunction. Okay? So my set builder notation, lowest number goes first, x goes in the middle, my positive, my highest number goes to the right. It's always the direction of less thans when you sandwich them in between, and they're equal to just because of that sign that I highlighted in the beginning. Okay, so that's set builder notation. Interval notation, I'm going from -4 to +9, both included because of the equal to. And then graphically, on a number line, here's my -4, here's my +9. They are connected because it's a conjunction, and they're filled in because it's equal to. They're included. All right, the next one, you're going to either do guess and check, slip and slide, AC method, okay? So if I factor these, I'm going to get x plus 6 and 5x minus 2. Split down the middle, set it equal to 0. That's going to be a -6. This one's going to be +2/5. Okay, so set builder notation. Oh, sorry, forgot the sign here. All right, so my sign means it's an or. So it's going to be two separate inequalities, they're going to go in opposite directions like this, okay? So it's going to be x, so now your lower number goes to the left, so it's going to be x is less than -6, or x is greater than 2/5, because that's going to cause it to go in opposite directions. So the lower number is always less than, the higher number is always greater than. Okay, so there's my set builder notation. Now for the inequalities, I have to have two separate, okay? So if you read this, x is less than -6. So that's going to be from -infinity to -6. They're not included because it is not equal to. And then this is going to go from positive 2/5 to positive infinity. And again, neither of those are included. Okay, remember this symbol in the middle is called the union, which means or. All right, so graphically, so here's my number line. I have my negative number, which is -6. My positive number is 2/5, that's about 0.4. And they're open, shooting out towards infinity. Okay, so think of this. Think of the ors, which are greater thans or greater than equal tos. Those are called disjunctions. They're disconnected. Okay, so they don't connect. All right, so for part B and C, or I'm sorry, B and D, you have to move everything to one side, but please make sure you remember to keep your x squared term positive. All right, so I'm going to minus the 10x, minus the 10x. I'm going to add an 8 and add an 8. So then I'm going to be left with 2x squared minus 14x greater than or equal to 0. So paying attention to greater thans. You know that's an or, you know it's a disjunction. They're going to be shooting out in opposite directions. All right, now this is a GCF, so I'm just going to factor out a 2x. And when I factor out a 2x, I'm left with x minus 7. You're still going to set each of those equal to 0. So this one's pretty easy, you get 7. But if you need to see the work on this one, to get x by itself, I divide both sides by 2, and I end up with a root of 0. So my answers are 0 and 7. Now remember, it's a disjunction, so the lower number is less, so x is less than 0, or x is greater than 7. For interval notation, you're at -infinity, approaching 0. I'm sorry, it is included, guys. It's equal to, so please make sure you have the equal to's. So 0 is included, infinity never is. Or, starting at 7, you're going to positive infinity. On a number line, start with your lower number. So here's 0, here's 7. They are disconnected because it is a disjunction, so they're shooting in opposite directions. Okay? They're included, so I shaded them. Last one here, I'm going to minus 14x, minus 14x, minus 19, minus 19. So I'm going to get x squared minus 25 is less than 0. And paying attention to it being less than 0, okay, that's an and, that's a conjunction, so they're connected. Okay, so think conjunction, connected, C-O-N, C-O-N, disjunction, disconnected, D-I-S, D-I-S. All right, that's a DPS, so I'm going to factor that. I'm going to get x plus 5, x minus 5. When I set each of them equal to 0, I'm going to get x is -5, and x is positive 5. Now remember, it's a conjunction, it's connected. So lower number to the left, x in the middle, highest number. Okay, and then they're always less than or equal to. Oops, this is not included, so they're not equal to. All right, that's set builder notation. Okay, so you're going from -5 to positive 5, not included. There's my interval notation. And then here's my number line graph. Okay, they are open but connected. Okay. Example 42. Okay, so right from the beginning, you can tell that they are connected, so it is an and. So, because it is an and, you know it has to be less than or equal to. So you can get rid of choice 3 and you can get rid of choice 1, okay? Then they're shaded, they're filled in, they're included, so it has to be the equal to one. Therefore, it's choice 4 and you didn't have to do any math work there, okay? All right, the last one here, example 43, I'm running out of time. You are just, I'm going to continue with that one in a minute.